Hey everybody, welcome back to another video for the ICM 2.0 Python version. In today's video, we are going to start introducing variables by talking through system variables. And to do that, we are going to use the Do Now starter code from the lesson, which I have already made a copy of on the screen and remembered to make my text bigger this time. And I've added just a few little pieces. This code will be linked in the video description if you'd like to work on it with me. You can also find it in the curriculum itself, and we will pause so that you can do any of the additions yourself. So you can see it, this code comes with some instructions. This is meant as a do now for students to do at the start of the day. And it asks them to create an ellipse and center it to the current canvas. And it also, there's an extension about inscribing the circle so it touches all four sides. We're not going to do that part as much as we are going to focus on making sure that it's centered. So right away, when I look at my code, I notice something a little different is happening with my size function. I have these two chunks of code here that are identical, controlling my X and Y. And I don't totally know what it means, but I do see the word random in there. And I see this INT, and I'm just going to pause on it for a second and see if I can make a centered ellipse, and then we'll kind of revisit that. So I've hit run. I can see my canvas. I can't get like the size right away from line 4 like I usually could, but I can use my mouse to help me. So if I go on this side of the canvas, it's at, it looks like 385 is the width, and it looks like 145 is the height. So what did I say? 385 and 145. So I'm going to make an ellipse, and I'm going to do something fun. I'm going to write in 385 divided by 2 instead of doing the math. What we always have to remember is computers are just one big calculator. So we do need to understand the numeracy behind the decisions we're making. I'm taking a full width, I'm dividing it by 2. But we don't actually need to do all of the math ourselves in our head or try and like open up a new window to use a calculator. And that can be really refreshing as we are going through this. I'm going to do the same thing for the height. I'm going to do 145 divided by 2. And then I'm just going to make this like a decent sized ellipse. I'll make it 100 by 100. And I want to test to make sure this works. So I'm going to hit stop. I'm going to hit run. And already I'm feeling a little frustrated because I'm now understanding what these values were doing in my size function. They're changing the size of my canvas every time I run it. So if I hit play, I'm getting a different canvas every time. And in some of those, my ellipse might be centered, but in a lot of them, they're probably not. So this is where our variables can come in. We have these things called system variables, and system variables are really great in that they already are declared. The computer understands these words, and it understands that it is holding a specific piece of data from our program that will sometimes be constant and will sometimes change. The first two we're going to look at are going to help us solve this problem, and they are width and height. So the first thing I can do in my setup function, which if we recall only runs one time, whereas draw runs repeatedly forever, I can use a function called print, which is a native Python function that will work even outside of processing. And I can print the width, and I can also write that this is, oops, you know what? I'm going to tell it that it's the word width, and then I'm going to print the width. And I'm going to do the same thing for the height, just so it's labeled for me. And if I hit stop and then run, you'll see that down at the bottom, it opens this little console. We'll also see error messages here sometimes. And it's printing the word that I asked it to print and then a number. Right now, my width is 295 and my height is 386. I can stop and run again. It will keep telling me those values. It's amazing. And I don't just have to print these words. I can actually use width, the variable, which notice does not have any quotes around it. It is something the computer is understanding and reading for value, and height, the variable, in my code. So instead of having these numbers 385 and 145, numbers that we refer to as being hard-coded because they are not changing, I'm going to put in variables of width and height, both divided by 2, and then I'm going to run my program. And now, whatever value is being printed to my console here, whatever value is stored in the width and height variable, that's being plugged into my ellipse function and then divided by 2 to make sure that my ellipse is always centered, even when things change. And I could, of course, use this. There are different challenges for you guys in the curriculum. I could use this to make something that's 1/4 of the way across the screen, 3/4 of the way across the screen, 1/5 of the way across the screen. I can use it in all types of ways to line things up and get things to appear the way I want them to, without having to worry about what if I change my mind and I want my canvas to be bigger or smaller in the future. I won't have to redo everything. This is super valuable and useful, and I know that it's making this program function, but for the purpose of the next pieces we're going to look at, I am actually going to make our canvas size pretty constant. I'm going to set it at 400, 400. And I'm actually going to comment out this ellipse for now. And I'm going to comment in this one under code along on line 18. If you would like to add this to your code, it's an ellipse at the center, 200, 200. I am choosing not to use width divided by 2 and height divided by 2, only because we are going to introduce new variables. And I think it's easier to just kind of see those on their own. And we're just going to work on this one for now. So right now, if I hit play, it's still printing my width and height. I can leave that in the console. But I want to talk about this ellipse, and I want to talk about our 2 new system variables. In addition to width and height, 2 of the other more useful things that we'll find in the processing module in the library is mouseX and mouseY. mouseX and mouseY hold the position of the mouse, that number that's like appearing in the corner of our screen, at any given time, which means it's a variable that is constantly updating and changing. All of these variables that we are using just represent a piece of data, and in this case, they all represent numbers. So anywhere that we have used a number before, we could use mouseX or mouseY. I'm actually going to show you this with the background first. I'm going to plug in mouseX, which we've actually seen on line 10 in our text function before. I'm going to hit run, and we see we have a black background now, but as I move my mouse across the screen, you'll notice that it shifts into a white background. And I could also do that with, I could do that with a color value. So right now mouseX is in the red position because I am in the default RGB value. Right now it's very blue. As I move my mouse, it becomes more purple and eventually magenta. This is an amazing option for everyone to try. And again, anywhere that there's a number, I could be using this. I'm going to set my background back to normal just so that we're not distracted as we keep going. As always, please feel free to pause and play. But I'm going to try using mouseX to control the size of something. So I'm going to have mouseX control the width of my circle. So now it's a line that looks silly, but I can extend that line out and I can make it really big. I could maybe have mouseY control the height of my circle. So it's going to start as like a little tiny dot. And then as I move, my circle is going to shift and it does all kinds of cool things. So you can see, whereas before we were making these programs that were a cool chance for us to code, they weren't super interactive. By just taking some data about where a user's mouse is, my program is already becoming slightly more interactive, which is really, really fun. And it doesn't have to just be size or color. I'm going to change my size back to how it was. I could make things that follow my mouse. So instead of having this ellipse always at 200, 200, I can put it at mouseX and mouseY, or just one or the other if I saw fit. And now when I run it, that ellipse is going to be attached to my mouse wherever my mouse should go. This is so much fun. You're going to have a blast experimenting with it, but it can get a little tricky when you start to introduce things like triangle or quad or begin shape, where there aren't just 2 coordinates it needs to follow. What if we want a shape to follow our entire mouse? So let's comment in this triangle. Please pause if you'd like to add this to your code. It is triangle 50, 50, 75, 10, 100, 50. You can get that in, and just remember that the first 2 numbers are 1 coordinate point, an X and a Y. The middle 2 are another coordinate point, an X and a Y. And the final are a last coordinate point, again, an X and a Y. If I play, I see that this makes a little triangle up near the top of my screen, and that's beautiful. But I want this whole triangle to move around with my mouse. So to do that, I need to pick one point that is going to be like attached to the mouse. When we saw it with our ellipse, we were talking about that center point. So the mouse, if I were to stop, the ellipse would have been right under it. The mouse would have been on top of the center. Here, I need a point to follow, and I am going to choose to follow 50-50. That's where my mouse is going to attach to. I'm just going to make a note so that I remember. Now, this can be a little scary, but I'm going to go into my code and I'm going to take away the 50-50, and I'm going to put in mouseX and mouseY. If we were to just run this as is, you'll see that I have my triangle and part of it is following, but the other two pieces are static. They're unmoving. They're exactly where they were. And so if I wanted to maintain the exact shape and like angle measures of this triangle, it's not going to work the way I intended. So I'm going to pause this, and I need to go through and I need to make sure these other points follow as well. My issue is if I turn every single one to mouseX and mouseY, instead of a triangle, I'm just going to have like a little dot that follows my mouse around, because all of those vertices are in the same point according to the computer. Instead of doing that, I'm going to think about this original point, and I'm going to think about the distance between that original point and my new places. So 50 to 75 has a distance of positive 25 between them. So instead of just writing mouseX, I'm going to write mouseX plus 25. 50 and 10 has a distance of negative 40 between them. So instead of just writing mouseY, I'm going to write mouseY minus 40. Again, I'm still using that mouseX and mouseY, but I'm preserving the distance by adding or subtracting amounts to where my mouse is. For my last one, I'm still thinking 50-50. 50 to 100 is a distance of positive 50. So this would be mouseX plus 50. And 50 to 50 is a distance of 0. So I actually don't need to add anything to mouseY. I can just leave it mouseY for that last value. Now I can test and see if I did this correctly. I can run. And look at that, I have a triangle that is following my mouse around. This is a wonderful skill to know, and it is definitely something that at least one person in your class is going to want to figure out at some point in time. Please use and practice it. If you refer back to the curriculum, you'll see that there are some challenges that you can walk yourself through to get more confident with these concepts. And just know that they are absolutely going to show up in future lessons and in future videos. I'll see you there. Bye.